Cast your mind back 350 million years. Forget the familiar rustle of leaves or the song of birds. The world that stretches before you obeyed entirely different laws, and the very atmosphere felt thick, like warm syrup poured slow. We find ourselves at the heart of the Carboniferous period, an age when nature was running its boldest and most terrifying experiments. In the shadow of towering club mosses whose crowns dissolved into low gray clouds, creatures lurked whose mere mention makes modern blood run cold. Picture a millipede more than 2 meters long. This is no invention of Hollywood screenwriters, no nightmare conjured by an arachnophobe. This is Arthropleura, a titan among arthropods, a creature whose armored shell caught the dull gleam of an ancient sun. And looking upon that magnificence, we can only feel a quiet relief that between us and that world lies an unbridgeable abyss of time. The land of that age was unrecognizable. Had we been able to look down upon it from orbit, we would have found not a single familiar coastline. No Europe, no Americas, no Asia. All the landmass had been drawn into one colossal knot, the supercontinent Pangaea. A monolithic expanse stretching from pole to pole, surrounded by the wordless fury of Panthalassa, the greatest ocean in the history of the planet, covering more than half its surface. Only to the east did the shores of Pangaea meet the waters of Tethys and Paleotethys, whose depths today are almost entirely consumed within the body of the Earth. Only rare fragments of the modern Pacific seafloor still preserve within their structure an echo of those times, when they were part of Panthalassa's undivided dominion. The climate of Pangaea was harsh and full of contradictions. Deep within that boundless continent, drought and piercing cold held sway. A sharply continental climate turned vast territories into lifeless, stony wastelands, where snowless, frozen winters gave way to exhausting summer heat. But where the land met the warm waters of the oceans and along the equatorial belt, nature reasserted itself. Here, endless humid forests stretched on, saturated with moisture. This was a world of tree ferns, giant horsetails, and club mosses whose shapes strike us today as grotesque and alien. Here, in these damp cradles of life, a history was being written whose consequences we still feel. The name of this period, Carboniferous, or the Carbon Age, was not chosen by accident. We tend to think of coal as simply a mineral resource, but in truth, it is a monument to a global biological failure. 300 million years ago, nature ran into a problem. Plants had learned to produce lignin, an extraordinarily durable polymer forming the core of woody trunks. But the bacteria and fungi of that era had not yet developed the means to break it down. When enormous trees fell from age or storms, they did not rot as they would today. They collapsed upon one another, forming impassable tangles that gradually sank into swamps, preserved without access to oxygen. Billions of tons of carbon were locked inside the Earth's crust. This process triggered a tectonic shift in the composition of the atmosphere. Since the carbon was not returning to the cycle, carbon dioxide levels fell, while the concentration of free oxygen rose sharply. This was not a gradual change. The graph of oxygen levels during the Carboniferous resembles an ECG during a moment of agony. Violent spikes from 15% to an almost unthinkable 31%. We live in a world where oxygen stands at just 21%. And for us, the Carboniferous atmosphere would have been pure poison, causing immediate oxidation of living tissue. But for the creatures of that time, this supersaturated air became the fuel for an evolutionary explosion. On its powerful legs were sharp spines, turning each limb into a deadly snare. Meganeura was a creature of open spaces. It patrolled riverbanks and lake shores, riding the rising currents of warm air. Research suggests that at such a size, it would inevitably have struggled with overheating. Its metabolism was so intense it demanded constant cooling. Its flight was most likely a series of short but lightning-fast bursts. It was the embodiment of fury and speed, a predator capable of intercepting in midair not only other insects, but the first tentative vertebrates just beginning to explore the land. There is a hypothesis that its respiratory system was far more complex than that of modern insects, operating on a principle of forced air intake, which allowed it to sustain its enormous muscles in that dense, energy-rich atmosphere. But if Meganeura was queen of the skies, then below, in the shadowed undergrowth of the riverside zone, Arthropleura held dominion. This creature, weighing up to 100 kilograms, would have triggered a primal terror in any modern observer. Its segmented body, shielded by a heavy chitinous shell, steadily worked dozens of pairs of powerful legs, leaving deep furrows in the moist soil. The width of this monster reached 50 centimeters, a living armored train carving its path through fern-covered wastes. Yet despite its fearsome appearance, Arthropleura concealed a surprise. Analysis of its jaw apparatus reveals no developed mandibles or venom glands of the kind found in modern predatory centipedes. Most likely, this giant was a peaceful consumer of plant matter. It was semi-aquatic by nature, preferring to stay close to water where atmospheric density and humidity were at their highest. But even such a titan had its moments of vulnerability. The most critical period in Arthropleura's life was the molt. To grow, it had to shed its old shell. During those hours and days, the 2-meter titan became a helpless mass of soft flesh. Without a rigid skeleton, its own muscles could not support its heavy body on land. Under the pull of gravity, it could simply suffocate. During the molt, Arthropleura likely retreated into water or took shelter inside the rotting trunks of giant club mosses, digging deep burrows into the soft substrate. There, in silence and darkness, it waited until the new armor hardened, transforming it once again into the invincible lord of the undergrowth. The Carboniferous was a time when life was testing the limits of physiology. It was an age of gigantism, born of a unique convergence of circumstances, a chemical imbalance in the atmosphere, and the complete absence of competition from large vertebrates. This was a world where insects and myriapods ruled the planet, building ecosystems that would never be replicated in the history of the Earth. And every time we burn coal to heat our homes or run our machines, we are burning fragments of that very world. The remains of those very forests through which the shadows of Meganeura and Arthropleura once glided in silence and grandeur. It was a great age, and it left us as its inheritance not only fuel, but an understanding of how strange and magnificent life can become when given enough oxygen and enough time. Look upon these colossal creatures once more. Hard to believe, but behind the terrifying appearance of these giant centipedes, whose bodies resembled armored trains, there lay a remarkably peaceful nature. Despite a form capable of inspiring primal dread in any modern person, Arthropleura was in truth more of a humble gardener of its era. It did not pursue prey through the shadows of the fern forests. It moved slowly and majestically, processing dead plant material, converting fallen leaves and decaying trunks into the foundation for future life. At times, it may have scavenged carrion as well, acting as a sanitation worker in that humid, oxygen-rich world. Why did nature allow them to reach such extraordinary size? The answer lies in the unique generosity of that age. The Carboniferous offered its children ideal conditions, endless food supplies, and, more importantly, the complete absence of serious competition. Vertebrates were still taking their first uncertain steps on land. They were too small and too weak to challenge the many-legged titans. But every golden age comes to an end. When the Permian period arrived, the sky above the planet began to change. The humid, enveloping warmth of the tropics gave way to the harsh breath of drought. The lands around the equatorial belt began turning into lifeless deserts, and the great forests began to retreat. With them went the Arthropleurus. They did not lose in battle. They simply could not fit into the new, harder, drier world, and vanished as quietly as they had once appeared. Yet while these dramas of survival played out on land, the true cradle of life remained in the water. Turning our gaze toward the winding shores of the ancient supercontinent, We see vast, shallow seas flooded with brilliant sunlight. The continental shelf of that time was a true paradise, where an abundance of nutrients gave rise to life forms surpassing any imagination. Here, in the thickness of coastal waters and in river estuaries, sea scorpions held rule, creatures whose very name sounds like a verdict, yet whose story is even more remarkable. Contrary to widespread belief, these monsters were not the ancestors of modern scorpions or crustaceans. They represented a dead-end, yet dazzling branch of evolution that reached its apex precisely during the Carboniferous period. And if nature ever fashioned a perfect aquatic predator from chitin and claws, it was Eurypterus. Picture a creature nearly 3 meters in length, a true leviathan of the shallows, the largest arthropod ever to have moved through the waters of this planet. Its sole heavy armament was a pair of massive chelicerate claws studded with sharp spines. It was an active, agile hunter for which fish and other arthropods were mere easy prey. But Eurypterus had a curious relative, Hibbertopterus. If the first was lightning, the second was a living mountain. At nearly 2 meters in length, it astonished with its extraordinary width, more than 60 centimeters of armored flesh. Hibbertopterus did not chase its prey. It moved slowly and methodically across the sea floor, like a living combine harvester, gathering silt and small inhabitants with its specialized front appendages. Its grasping organs were too weak for combat, but its defense was absolute. Most remarkable of all, this heavyweight sometimes left its native element. Paleontologists have found in fossilized sediment the tracks it left. Deep grooves pressed by a heavy body dragging across the ground. Why did it come ashore? Perhaps to move between water bodies or to escape a drying pool. How did it breathe? That remains one of the greatest mysteries. Perhaps its gills could retain moisture long enough. Or perhaps it possessed a dual respiratory system, making it a kind of primordial amphibian among arthropods. We find only their shed shells, empty husks of former greatness, that keep their silence about how a heart once beat inside these titans. And above the waterline, forests rustled that resembled nothing we know today. This was a world without a single flower, a world of perpetual green twilight. There was no hum of bees, no birdsong, only the sound of wind in the crowns of giant club mosses and horsetails. Lepidodendrons soared to 40 meters, propping up the heavy sky of the Carboniferous with their column-like trunks. Their bark, covered in diamond-shaped scars from fallen leaves, resembled the scales of enormous serpents. These trees lived fast and died in mass, lacking deep roots but driven by an extraordinary will to grow. Alongside them in the boggy lowlands stood sigillarias, straight as arrows, reaching 25 meters in height. Their wood was soft and porous, but their bark was hard as stone. That very bark, impervious to decay in the stagnant waters of the swamps, is what became, hundreds of millions of years later, the coal that fuels our civilization today. We are quite literally burning the flesh of those ancient forests to light our cities. But if we leave these humid woodlands and travel across the boundless ocean of Panthalassa to where waves break against invisible underwater ridges, we encounter those who witnessed the very beginning of time, trilobites. These creatures were veterans of the planet long before the first millipede crawled onto shore. They had existed for hundreds of millions of years, adapting to every change. In the seas of the Carboniferous, they reached their final grandeur. Among them were their own kings, such as Isotellus rex, 70-centimeter lords of the seafloor clad in flawless segmented armor. Certain fragments of shell hint that some individuals reached nearly a full meter in length, true armored shields gliding through the darkness of the ocean. Trilobites witnessed the world change, watched mountains rise and fall, watched life attempt new and sometimes terrifying forms. They were the link between an unimaginably ancient past and the world as we know it. Looking at their fossils, we understand that Earth's history is not simply the succession of ages. It is a grand symphony in which every participant, from the tiniest trilobite to the 3-meter sea scorpion, played an irreplaceable role. And the echo of that symphony still sounds today in the flame of a coal furnace and in the silence of museum halls, reminding us how grand and strange the path of life was long before our arrival. 500 million years, a span of time the human mind can barely grasp. This was an era when the Earth itself was a different world, and the ocean was the cradle in which life honed its boldest and sometimes most terrifying designs. The trilobites we spoke of earlier did not merely inhabit these waters. They became their very flesh and blood, their enduring symbol across 250 million years. And though we will not encounter them in the waves along any shore today, their legacy has not vanished without trace. It lives on in the barely perceptible movement of a modern woodlouse, or in the heavy, archaic shell of a horseshoe crab that seems like a visitor from another reality altogether. These creatures are our living bridges into an age when the backbone was still only a bold experiment by nature. Look at a trilobite not as a fossil, but as a perfect engineering project. Across all their colossal diversity of species, nature adhered to a single flawless blueprint. A flattened body, divided into precise segments, was clad in a powerful exoskeleton, true knightly armor for its time. The head, sheltered beneath a massive chitinous shield, was the command center, housing advanced sensory organs and appendages that evolution had refined into tools for finding food. The tail, crowned with a sharp spine, served as both rudder and defense. Most of them preferred the concealment of the seafloor, working their many legs through silt and sand. But some dared to master the open water column, or burrowed deep into the ocean shelf. There was a strange, alien beauty to their forms. Thousands of tiny facets created a panoramic view of the ancient ocean, a planetary-scale optical achievement unlike anything that came before. Today, only rare deep-sea creatures, such as brittle stars or primitive mollusks, preserve something resembling this mineral optics. But their eyes are only a pale shadow of the optical perfection that trilobites once possessed. In this world where every creature sought its own niche, trilobites showed remarkable flexibility. Some peacefully filtered silt, others hunted plankton, while still others became predators themselves, despite the absence of powerful jaws. In moments of danger, they curled into an impenetrable ball, tucking their vulnerable undersides beneath the protection of their chitinous plates. It was a perfect survival strategy, and yet even it offered no guarantee of safety, for in the shadow of underwater rocks lurked one whose name became a synonym for primordial terror: Anomalocaris, the unusual shrimp, as its name translates. And in that name lies an irony, because this was the first super predator our planet had ever known, a titan of the now extinct class Dinocaridae. Picture a creature nearly a meter in length, a giant by the standards of the Cambrian period. But even the magnificence of Anomalocaris could not save it from the relentless march of time. By the close of the Cambrian, these lords had vanished, unable to withstand the shifting climate and the pressure of new, more capable competitors. Life continued its journey, but ahead lay a trial without equal. The Great Permian Extinction was the final chord of the Paleozoic era. It was a catastrophe of planetary scale, an apocalypse that erased from the face of the Earth 96% of all ocean inhabitants. 80% of land species vanished into oblivion. The enormous insects, the titanic arthropods that had ruled the world for millions of years, disappeared almost entirely. This was the point of no return. The world was emptied, but hidden within that emptiness was the seed of the future.